Hi students. Today we're going to study about probability and questions American cycle and the questions that are related to set 2, and even you're going to see it in the IB, same for the IB program. So definition: a universe is a set which is finite and not empty. So where we're going to do our probability or experiment. It consists of elements, for example, cards, 52 deck of cards. We know that we have 52 deck. For example, if you want to students in your classroom, so this is also what the elements. The elements are called eventualities, and any subset more than one is called event. If you have two events A and B, A intersecting B are all common, or eventualities coming to A and B. Union, it can be in A or in B. So if I want to do a picture, suppose you have a set A and you have a set B. This is A, this is B. The common will be A intersecting B. So here A intersecting B, the common. A union B will be either in A or in B, so everything. So that's why if you want to find, for example, we're going to see it later, P of A union B, probability of getting A or B, you do P of A plus P of B. Since you are adding A, so the common is in both in A and in B. So this common exists both here and here. So we cannot add it twice, so we do -1 intersection. So A of A union B, A of A union B is PA plus PB minus, this formula is important, you need to memorize it. So what's if you have an event A, P of A, for example, picking for example a girl in the class, I have 5 girls out of 20. So 5 girls out of 20, so which is 1/4. So A bar, it means the complement, not in A. If you have 5 out of 20 are girls, so the rest will be P of A bar. P of A bar in that case, the complement, the rest, it will be 1 minus P of A, so it will be 15/20, 3/4. So if you have, this is set E, set A bar will be everything outside, everything not in A. So that's why PA plus PA bar is always equal to 1. So PA bar plus PA is always equal to 1. And A union A bar, if you make A plus everything outside A will be everything the universe. And nothing in common between A and A bar. So A bar is the complement. First definition, what do you mean by incompatible events or mutually exclusive? Two events are said to be incompatible or mutually inclusive when they don't have intersection in between. Let us take an example. You have this universe, you have 3 red ball and 2 violet ball. In another, you have event A, you have 2 red. In the event B, you have V3, V4. And C, you have a combination of red and violet. A and B are mutually exclusive. Why A and B are mutually exclusive? Because nothing in common. However, A and C are not mutually exclusive or not incompatible because they are here they have R index 2 and here they have R index 2 in common. And same for B and C. So this is not mutually exclusive. So always mutually exclusive or incompatible, we will get that A intersecting B is empty. So in that case, so you have two events A and B and nothing in common. So that's why if you want to do P of A union B when incompatible, it will be PA plus PB only. We don't have P of A intersecting B because this is 0. Okay? And here, this is the formula we're talking. So if it's a mutually exclusive, P of A union B is PA plus PB, as I said. P of A bar is 1 minus P of A. P of A plus P of A bar is 1. P of any universe, if the whole universe is 100% true, you know, what is the probability of picking a card from a deck of 52 cards? So 100% I'm going to pick a card. Okay, what P of empty set is 0. Okay. First of all, I'm going to start by the probability. Probability, as we said, is number of favorable cases over total number of cases. What is the probability of getting a 5 when throwing a dice? So you all know I have 1 5 in the dice out of 6, so it will be 1 over 6. What is the probability of picking, for example, a heart from a deck of 52 cards? So it is, for example, a heart, number of favorable cases. So how many heart I have? So it's 13 out of total, out of 50. So always probability of an event is favorable number of choices over total number of choices. What the probability of picking a king? I have 4 king over 52. Jack, heart, jack. So I have 1 heart jack in the card out of 52. Okay. For example, in this example, what the probability of picking a heart? Someone is going to tell me it's 1 out of 13. I have 1 out of 13 over 1 out of, I want to pick 1 out of 13 over 1 out of 52. It's the same as writing it 13 over 52 because I'm going to pick only one card. Now we're going to talk about dependent events. We know in counting dependent events, if either it's a combination or arrangement. If order is important, it's called arrangement or permutation. If order is not important, it's called combination. So here I'm going to take examples of how to find the probability when you have independent events. So we're going to start by number 1. Let A and B be two events of a certain universe. You have P of A, you have P of B. You want to find their union. We know that P of A union B is PA, as you know, plus PB minus P of A intersecting B. In the first example, they said that in part A and B are incompatible. What does it mean incompatible here? That the intersection is 0, so P of A union B will be PA plus PB, which is 0.9. B subset of A, what does it mean? Does it mean B is subset of A? So B is inside A. This is B subset. This is the symbol, you know, of A. So B is inside A. So if you want to find the union, so the union will be everything, which is A, because B is inside A. So it's directly B subset of A. So P of A intersecting B is PB, the intersection. And the union directly, if I want to do it, is you can write it directly. It's P of A. No need to write all of these. No sense. So P of A union B is PA, and PA is 0.5. And if A intersecting B is 0.3, you apply the formula. PA is 0.5, PB is 0.4, and the intersection is 0.3. So the answer will be 0.9 minus 0.3 is 0.6. So always if they ask about P of A union B, this is the formula. Now we're going to start by probability direct application problems. Consider a NER containing 10 red balls and 5 green balls enumerated. No need to say here, I have erased it before and I forgot to take it. We have 10 red and 5 green. We need to draw 5 balls from the earth. So أكيد without, certainly without replacement, because they didn't say with replacement. So when they say without, they don't. If when they don't mention, it means without replacement. Find the probability of drawing 2 red and 3 green. So because the events here are dependent. What does it mean dependent? يعني every draw depends on the previous one, because I'm going to draw the ball, I'm going to keep it with me. So that's why the second draw, instead of having 15, we're going to get 14. So these draw depends on each other. So this is called dependent event. So since I'm going to do a dependent event, I solve it as I used to do it before, either combination or arrangement. So what's the difference between counting and probability? So we do the counting that we used to do. I want 2 red, so it's 2 out of 10. I want 3 green, is a 3 out of 5 over what total. So how many draw I want to get? I have 5 out of 10. It's like accounting, we're doing it combination, but I divide it by the total. So if you use your calculator, you're going to get 0.15. I want 4 green, I'm going to draw 5. 4 green in 4 out of 5, and remains 1 red, because I have 5 draw. 4 out of 5 and 1 out of 10 over total. because the question is about probability. So this is the answer. I want the first and the third are the only green. Because here I have order is important. I want the first green and the third green, and I'm going to draw how many one? 5. So here I have red, here I have red. So order is important. I do it arrangement like I used to do in counting. So I have 2 green and 3 red, 2 green, 2 out of 5 arrangement, and 3 green, 3 red, 3 out of 10. Over total arrangement is 5 out of 15. Okay, maximum 2 green. Here we didn't talk about order, important. So either you may have 0 green, 0 out of 5, and 5 are all red, or 1 green, 4 red, or 2 green and 3 red over total. So what do you realize the difference between counting and uh, probability? In probability, if the events are dependent, like this one, like these problems, we do either combination but over total combination, or arrangement over total arrangement. So it's similar to the things we did before in counting. We draw 3 cards from a deck of 52 cards. What the probability of getting 2 aces? Also, order here is not important. I want to draw 3 cards, so 2 aces, 2 out of 4 remains 1 card, not ace. Not ace is 48 choices over what total combination. I want out of the 3 cards the ace of heart. I have 1 heart, 1 out of 1. 2 out of 51, the rest of the cards, over total 3 out of 52. Not a single heart, 0 out of 13. 3 cards not hearts, it can be spade, club, diamond, 13 plus 13 plus 13, 39 over the total. The first 2 are kings only. So here order is important. I want the first 2 must be kings. So here in this choice, I want king, then not king, not king, any king bar, anything except king. So here I have 2 kings out of 4. Arrangement order is important, as you can see. And 1 out of not king. Not king in the cards are 48 over total 3 out of 52. And the last one, 2 hearts followed by a spade. So order is important. So arrangement 2 out of 13 and 1 out of 13 over arrangement 3 out of 52. So as if we're solving counting problems like we did before, but the difference here is that the question is probability, so I divide by the total number of draw out of the total universe, the elements inside. Okay, my email code is formed of 2 characters followed by 2 characters from the English alphabet. We know we have 26, followed by 3 digits, such that all are distinct. Okay, not a digit similar to the others. Why? Because I want it to be dependent, because if they are this, if I can repeat the same digit, it will be independent. There is another formula, we're going to talk about it anyway. So here, how many possible outcomes you may get? As you know, the code, the order is important, so it's an arrangement. I have 2 characters from the English alphabet, so 2 out of 26, as you can see. And I have from 0 till 9, I have 10 digit numbers. I want 3 out of 10. So this is the total number of outcomes. Here the question is not about probability in part A, it's counting. In the second one, find the probability to open the code for a randomly pick. So you all know you have 1 choices out of this total. So I have 1 choices will open the code, the email, out of how many choices? 468,000. So that's what I wrote. We need to elect a president, secretary, and 2 directors from a group of 12 boys and 14 girls. Find the probability of picking 2 girls and 2 boys. We know when we pick director, secretary, whatever, here the order is important, because if the person is picked secretary and another one director, we cannot switch. It will be different. So that's why it's an arrangement, as we solved it before in counting. I need 2 girls, so 2 out of 14, 2 boys, 2 out of 12 arrangement over total. So it's like accounting, as we said, I'm repeating myself always. Over total, I'm going to pick 4 out of how many? 126. Maximum 1 boy. You may have 0 boys, 0 out of 12, and the rest 4 are girls. Or 1 boy and 3 girls over total. Now, independent events, which is called P list. You know the P list. If independent events, if the relation does not depend on each other, what is the probability of getting A and B? So it's PA times PB. As an example, suppose you want to flip a coin. What is the probability of getting a head then a tail? You're going to tell me the tail does not depend on a head because it's independent on each other. So P of the first times P of the second. I don't do it anymore combination or arrangement. So in independent events, I do each draw by itself. And I mean, if I have, for example, 3 events I want to do. I want to pick, for example, marbles from an urn. What is the probability of getting the first? I want to such that I will pick the first one. I return it back. I will pick the second. I will return it back, and then I repeat the third one. This is called in counting P list. So suppose I said I want a green, then red, then green. So you're going to tell me because draw are done with replacement. So I do P of green, each draw alone, not like before, arrangement over total or combination over total, times P of red, each draw alone, times P of green. But you need to know one thing. When I write green, red, green, it means the first ball I'm going to pick or marble is going to be green. The second one is red, and the third one must be what? Green. So here in order is important. But suppose I said I want 2 green and 1 red, so I need to, and I didn't mention that the first one must be green. So if I will write this one only, this will be wrong. Why? Because when I say green, red, green, as I said, the first one is green, red, green. You may have red, green, green, or 2 green and red. So not to do this mistake, there is a formula, Bernoulli trial formula, which will states when order is not important, you use this formula. For example, we're going to talk about it. K is the number of success. For example, suppose I said I want to draw this one. I want the success to get 2 green. So I have, suppose I have I want to do this trial 3 times. I want to get 2 green. So how many success I have? 2. Combination 2 out of how many trial I have? 3. P of getting a green, success power 2, for example, 1 minus not getting a green, 1 minus, it means the P of green not getting a green, and this is the failure, which is the difference. If I have 2 times I want to get green out of 3, the failure will be what? Power 1. We're going to see it in a problem, in the problems now after. So what I want to say, if you have independent events, you do each one alone, one after the other, each draw alone. We don't do it like we used to do here, arrangement over total or combination over total. So this is only when you have depending events. The P list that you know in counting will be done that sort. Each draw will be done alone. So let us see what I mean. What is the probability of getting a head followed by a tail? You know, uh, when you want to flip a coin, it's independent. It doesn't mean if I have a head, I have a certain probability for the second one to get a tail or vice versa, because flipping a coin is independent. So I want a head first, then a tail. So I do P of head times P of tail, each one alone. So it's one, getting a head is 1 over 2 and getting a tail is 1 over 2. So the answer will be 1 over 4. But you need to know, as I told you, that the first one will be head and the second one will be tail when you write this one. For example, what the probability of getting a head and a tail? I didn't tell you a head then a tail. So what is the difference between the two? Because here it's independent. In the first one, I want head and then tail. Here I want head and tail, okay? And I know it's independent. So if I write only P head times PT, so I know that the first one must be head, then tail. But what about tail before and head after? Independent events, the things we did before, dependent with replacement, I didn't have this problem. Why? Because if order important, I go directly to arrangement. If order not important, I go directly what? To combination. So that's why if you put P head then times P tail, you must put P tail then P head. You must put 2 choices. So it's 1 over 4 plus 1 over 4, which is half. You're going to ask me, you told us, if you have order is not important, use this formula. Yes, you can use it, but this is very simple to do it directly. No need to put the formula. If you want to put the formula, you want a head and a tail. You pick one of them to be success. Suppose you want to pick head to be success. You put 1 out of 2 trial because you want to flip the coin twice. Probability of getting a head is 1 over 2. What is the success? I want it 1 times. 1 time. 1 minus half to get a tail, which is also half. The failure is what? 1. So it will be the same as we did it here. It will be 1 out of 2 is 2. 2 times half, it will be half. Let us take more example. Let A and B be two events of a certain universe. You have P of A, P of B. You want to find P of A union B. And they told you the events are independent. You know that if you want to find P of A union B like we did before, it's PA plus PB minus P of A intersecting B. But because the events are independent, P of A intersecting B is PA times PB. If they are mutually exclusive or incompatible, it will be 0. Remember, we did it before. But because it's independent, P of A union B is PA plus PB minus P of A intersecting B, where P of A intersecting B is PA times PB. So if you do it, you're going to get this answer. Consider an urn containing 10 red, 5 green balls. Enumerate without enumerating, because I'm doing sometimes copy paste. We need to draw 3 balls from the urn by replacing the first draw before drawing the second. Because I want to pick and then I replace it, then pick the second, replace it, pick the third, replace it. This is independent, so I do it as like P list but in probability. Find the probability of drawing 2 red followed by a green. I want 2 red, so because independent, I do P red times P red times P green in order. So to pick a red, if you want to do it like we used to do before in counting, how many red I have? I have 1 out of 10 over total. What is the total? 1 out of 50. So because I have only one draw, you can do it directly. Favorable over total, 10 over 15. Times 10 over 15. And the green, instead of saying 1 out of 5, 1 out of 5, because I want one green over 1 out of 15. Because in independent, we're drawing only one. So 1 out of something is something. So 5 over 15, so the answer is 4 over 27. But suppose we want to do it without replacement. So what do? You do as we did before. It will be, because order here is important, we do it arrangement. So it will be, I want 2 red, so it will be arrangement 2 out of 10, then followed by a green 1 out of 5 over the total, which is 3 out of 15. This is what when we have without replacement. But since we have replacement like here, we don't do it like we used to do before. We do it what? P of the first times P of the second times P of the third. I wanted 3 green, so P green, P green, P green, so no other choice. Getting a green is 1 out of 5, as we said, over 1 out of 15, so 5 over 15. How many times I wanted? 3 times. 2 red and a green. Here I didn't say the first 2 are red, then a green. I want 2 red and a green and independent. If you want to do it like we did before, all step, you put P red, P red, P green, plus P red, P green, P red, P green, P red, P red. These are all choices. You cannot stop here. If you stop here, you're telling me the first one is red, the second one is a red, the third one is green. Because in P list, we don't have a formula for order important and order not important. So always order important. And if you have order not important, you must put all choices. So here it's the same answer, 4 over 27 for each one times 3. If you want to do Bernoulli, so you're going to say, suppose I want the success here, the red. You can pick whatever you want. So I want to pick how many balls? I want 3. I want out of these 3, 2 red. So the success, I have 2 choices. 2 choices out of 3. So success here red, P of red squared, because I have it twice. And 1 minus P of red, failure will be what? Not red, power 1. So we know that combination 2 out of 3 is a 3. P of red is what? P of red, picking 1 red. We did it here. 1 out of 10 over 1 out of 15, which is 10 over 15. 10 over 15 is 2 over 3. So I have it squared. 1 minus 2 over 3 here is 1 over 3 and power 1. If you want to pick the success to be the green, so out of the 3, I want 1 green. So 1 out of 3, because I have 3 trial. P of what? Success I picked to be green. Failure will be 1 minus P green. How many times failure I have it? 1 minus 3. 3 minus 1 is 2. We know that P of green is 5 over 15, which is 1 over 3. Combination 1 out of 3 is a 3 times 1 over 3 times 1 minus 1 over 3 is 2 over 3. I have it failure twice, so it's the same answer. Please look at it. Think about it. It's very simple. We draw three cards from a deck of 52 cards with replacement. Since we have it with replacement, it means that we have independent events. What is the probability of getting 2 aces only? So P aces times P aces. Sorry, there is something wrong here. Not 3 cards. Here the question is, let me see. In the first one, 2 aces only. So let me do each one because I have solved it. This is wrong if I want to keep 3 because I have here 2. So let me do it. Suppose you have 2 aces only from 2 try. Forget the 3 for the first one. I'm going to do it for 3 next to it. I want 2 aces out of 2 tries. So because independent, I'm going to return back the card. It's PA times PA. How many choice of aces you have? You know you have 1 out of 4 over total 1 out of 52, so 4 over 52. 1 out of 4 over 1 out of 52, 4 over 52 is 1 over 169. Suppose the question is 2 aces from 3 try. So here you can say ace, ace, not ace, anything not ace, or not ace, 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 or ace, not ace, and ace. Instead of doing it this way, because independent of events, I want 2 aces out of 3. So I put 2 out of 3 combination. P of success, probability of getting an ace, 1 ace, you know it's 4 over 52. So the success is twice. The failure will be 1 minus 4 over 52. How many failure you want? If you have 2 correct out of 3, it will be 1 correct. Okay? Ace of heart followed by a spade. Only here I want to do it for 2 trial. Draw. So P of ace of heart followed by P of spade because order important. Ace of heart, you know they have 1 ace of heart. So 1 out of 1 over 1 out of 52 combination. It will be 1 over 52. And then spade, you all know it's 1 out of 13 over 1 out of 52. So 13 over 52. A heart and a spade. Suppose here, come in, I have 2 trial. So the second is the only heart. So sorry, here we did a heart and a spade. No, we did it. No, a heart and a spade before C. So a heart and a spade independent because don't forget with replacement. Or P spade then P heart. You cannot keep here because if you keep this one in the heart first come then spade. No, I want 2 choices. So P of heart, I have 13 choices out of 52, or combination 1 out of 13 over 1 out of 52. Same for spade. Instead of writing it twice, so times 2. The second one is the only heart. So here order important and independent. So P of heart bar, not heart, then P of heart. Not heart, I have 1 out of 39. Not heart, you have 39 cards, not heart. Over 1 out of 52. So it will be 39 over 52. and P of heart 1 out of 13 over 1 out of 52, so 13 over 52. One heart only. So here كمان two trial in part D we did it, okay? هلا in E I want one heart only from 3 trial. Okay? So I have one success, one heart out of 3. Because independent, I can use Bernoulli formula. So P of heart, I want one success, and this is the failure power 2. P of getting a heart, you all know, I have 13 heart out of 52, power 1. And the failure is 39 over 52, not heart, power 2. My email code is formed of 2 characters from English alphabet, followed by 3-digit numbers. How many possible outcomes you may get? Because here I didn't say distinct like we did before. You can use the character more than one time. So it's a P list. You know that's a P list, 3-digit and power 3. And if you want to solve, find the probability to open the code for a randomly pick, I have only one choice out of the total like we did before. But here we did it as P list. We throw 2 dice. You all know when throwing a die, independent, because the second pick does not depend on the first one. Find the probability of getting one number 5. So you may have 5, then not 5. You can see it here, or not 5 with a 5. If 5 is 1 choices out of 6, not 5 is 5 choices out of 6 times 2. Both numbers are 5. I forgot to do this one. So you do P of 5 times P of 5. So I have 1 out of 6 times 1 out of 6. It will be 1 over 36. All here, the cases are independent. We flip a coin 7 times. So independent flipping a coin because the draw are not related to each other. Find the probability of getting 3 heads. So how many success I have? Bernoulli formula. I have 3. So the head is a 3. The failure will be tail. 1 minus head. Yani what does it mean? 1 minus head. It means a tail. Power what? Failure 4. 3 out of 7 combination is 35. P of head, you all know to get a head. Always for one draw you do it. P of head is 1 over 2. Cube is 1 over 8. And a tail, 1 over 2 power 4, 1 over 16. You get this number. So if you want to summarize till now, everything dependent, you do it arrangement over total or combination over total. And if you want to do, I need to close my phone because it stop ringing. And if you want to do independent like these, which is called P list in counting, you do P of the first times P of the second times P of the third, each draw alone. And order here is important. And if you want to put order is not important, you can do Bernoulli if you want. Problems. So we're going to start by the problems. What is the probability of getting a sum of 7 when one die is thrown? You know we don't have in 7, impossible. What the probability of getting a sum of 7 when 2 dice are thrown? We know you have 1 1 1 2 2 1 3 1 6 2 1. You have 36 choices, 6 1 6 6 2 6 3 whatever. I want sum of 7, so you have 1 6 6 1 2 5 5 2. Why I'm doing this? Because P of 1 times P of 6 independent is different than P of 6 times P of 1. Because if I say 1 then 6 in the first one is going to come 1 and then 6. What about getting 6 in the first throw and then 1? So that's why in independent you must put all choices. So if you count it, you have sum of 7, 6 out of 36. If 2 fair coins are flipped, you know this is independent because you're flipping a coin. What the probability of getting 2 head? So here P head times P head. Okay, so independent, so it's 1 out of 4. If 3 fair coins are flipped, what probability of getting 2 head? Come in, it's independent, so Bernoulli, I have 2 choices out of 3. P of head, because I picked the failure to be here the head. You can pick to be tail. Instead, you put 1 out of 3 because if 2 head in 1 tail. I picked to be head square and P tail failure 1. We know that P getting ahead is 1 over 2 square 4, 1 over 4, and P of tail 1 over 2. Or if you want to see it, here we're flipping 3. Either you have had, you know, I'm not going to start counting. For example, had, tail, had. You have 8 choices. Had, tail, had, tail, had. If you count it all, you have 8, so I have 3 out of 8. If the probability that John will buy a certain product is 3 over 5, Bill will buy that product 2 over 3, that Sue will buy that product is 1 over 4. What is the probability that at least one of them? When you have a question and the question is independent, remember what I'm saying. If independent, because each one is alone is going to buy, there is no connection between these. If I ask you, what is the probability of at least one will buy, you do 1 minus none will buy. Yani all will not buy. All are correct, all are accepted, except if all will not buy. So everything, suppose for example, if you want to go to the market and you and your 2 brothers, each one has a probability to buy. The only thing to say, if I'm asking you, what is the probability at least one of you, you're going to tell us all possibilities are accepted, except 3 of us at the same time are not going to buy. So I will do our she none will buy. Always, if independent and if the question about at least one, you do for all none, because independent, P of John bar, P of S bar, P of B bar. If John will buy 3 over 5, you do 1 minus 3 over 5. Here 2 over 3, 1 minus 2 over 3. Sue is 1 over 4, 1 minus 2 out of 4. The answer is 1 over 10. So this is none will buy. To do one, at least one, it will be 1 minus 1 over 10. So we're going to do many problems. You will understand it later. What the probability of drawing a spade or a king from a deck? So here, as you can see, with the, I didn't say with replacement. So you all know, in all cases, I want to draw only one card here. How many spades you have in the card? 13. How many kings you have? 4. But you have one common, the king of spades, so you don't count it twice, so it will be 16. So it will be combination 1 out of 16 over 1 out of 52. So the answer will be 16 over 52. If a coin is flipped, خلاص, directly independent, and one die is thrown independent, what the probability of getting a head and a 4? A head, then I want to say then a 4. I forgot to write then a 4. First of all, I want to flip a coin. You have after. If a coin is flipped after one die is thrown, so here order important. So we do what? P of a die of getting a 4, then P of head. Getting a 4, you have 1 choices out of 6 times 1 out of 2, 1 out of 12. Suppose the question, I don't know by what I want to begin, so I multiply it by 2. It will be P4 P head plus P head, then P4. If a coin is flipped after a die is thrown, what the probability of getting a head or a 4? So you can say P of, so here order is important. We know getting a head or a 4, like we did up here. At least one. P a head or a 4. So I do not head, not 4. 1 minus both not, like we did up. So none. P not head, 1 over 2. P not 4, 5 out of 6. So it will be all number except 4. So I have 5 choices. So I do 1 minus 5 over 12. 2 cards are drawn from an ordinary deck of 52 cards. Each card is placed in the deck before the next card is drawn. What is the probability that at least one, at least one, as we did up, 1 minus none of the card is a spade. I want to draw 3 cards, so I say suppose all not spade. So P S bar, P S bar, P S bar. I do 1 minus P of S bar. Not getting a spade, so you all know you have 1 out of 39 over 1 out of 52, so which is 39 over 52. I have it 3 times because with replacement. So 1 minus this one, you're going to get that one. A class has 12 boys and 4 girls. And if 3 students are selected at random, what the probability that all are boys? So here we don't have any more Bernoulli formula, nor P of the first times P of the second, it's times P of the third, because dependent. You know, I want to pick, we cannot pick the same student more than one time. So here, all are boys. So how many one I want to pick? 3 students. So 3 out of 12 over 3 out of 16. A red box contains 8 items, of which 3 are defective. So red box, you have 8 items. We have 3 defective, 5 not defective. And the blue, 5 items, 2 are defective, 3 not defective. Okay, so I have 2 boxes. An item is drawn at random from each box. So أكيد they're independent because the draw from here does not depend on the draw of the second. What the probability that both items are not defective? I want to pick not defective. So I will say, because independent, I'm going to pick from the red and from both not defective. So I say not defective. Here it means when I put this one knowing from A, because I'm in which one? In the first, this is A, box A, and this is box B. So not defective of knowing from A and not defective knowing from where? From B. Not defective here. So I have 5 choices out of 8, as you can see here. Here from B, I have 3 choices not defective out of 8. Okay. A red box contains an item, as we said, what probably that one and only one item is defective. So it can be non-defective from A, but the defective is from B, or it can be the defective independent, as we like up, defective from A and non-defective from where? From B. Not defective from A, it means 5 out of 8. Defective from B, you have, as you can see here, 2 out of 8, or defective from A you have 5 out of 8, sorry, defective you have 3 out of 8, and non-defective from B is a 3 out of 5. The same question, at least one, so it is defective. So I do both not defective, 1 minus not defective. Okay, this is not defective, 5 out of 8, 3 out of 5, I do it 1 minus. If 10 coins are flipped and the first 5 all comes head, what is the probability that exactly 3 more heads will be flipped? So I know that the first 5 are head. Remains, because I have 10 times I want to flip, remain 5 times. So how many head I want? 3 more. So how many success? Because independent, because flipping a coin, throwing a dice. So 3 out of 5. Getting a hat, you all know 1 over 2, the success is a 3. 1 minus 1 over 2, the failure is 2. We want to roll a dice 7 times. 5 probability of getting 4 times the number 3. I want 4 success out of 7. Getting a number 3 is 1 over 6. Success is 4, and the failure will be the difference, 7 minus 4, 3. We want to roll a dice 10 times. Find probability of getting 6 times a prime number. You know that prime numbers are 2, 3, 5 divisible by themselves only. So how many choices, how many success I have? I want 6 prime number out of 10 choices, 6 times out of 10. So probability of getting a prime is 3 over total, which is 6. And this is the failure, 1 minus 3 over 6, 4 times. We draw 10 cards from a deck of 52 cards with replacement. So Bernoulli degree, okay? Find the probability of getting 3 hearts. So how many success I have? 3 out of 10. Getting a heart is 1 out of 13 over 1 out of 52. So 13 over 52 success is a 3 times. Failure will be power 7. We draw 10 cards from a deck of 52 cards. Here we don't have it with replacement, so I don't do it Bernoulli. I do it is if order important arrangement, if order not important combination, because it's dependent of getting 3 hearts. So I have 3 hearts and 7 not hearts, not heart 39 like we did in counting over total 10 out of 52. Two cards are drawn from a regular deck of 52 cards. What the probability that both are 7? So also, I want to draw without replacement. How many 7 I have in the card? I have 4 choices, so 2 out of 4 over 2 out of 52. 7 cards are drawn from a regular deck of 52 cards. What the probability that 2 cards are 7? So I want to draw 7. 2 are 7, 2 out of 4, and the rest are not 7. Not 7 in a 48. Combination over total, which is 7 out of 52. 21, yalla, we're reaching the end. We have till 29. 21. 7 cards are drawn from a deck of regular 52 cards with replacement. With replacement, Bernoulli. What is the probability that 2 cards are 7? 2 cards are 7. I want 2 success out of 7. 2 out of 7. What is the probability of getting a 7? 1 out of 4 over 1 out of 52. So 4 choices over 52. Success is 2 and the failure 1 minus, and failure is 5. If the probability that of a certain team will win is 3 over 4, what is the probability that the team will win the first 3 games? Come in independent winning and the game. There is no relation. And lose the fourth. Yani winning the first 3, then lose the last one. In winning is 3 over 4 power 3. Lose, it will be, if winning 3 over 4, the loss is 1 over 4. So 1 minus 3 over 4 power 1. If the probability of a certain team is winning the same question, 3 over 4, what is the probability that this team will win the win 3 games only out of 4? So here, because independent order is important, I go to Bernoulli. I have 3 success out of 4. Probability of success is 3 over 4. I have it 3 times. Failure is 1 minus 3 over 4 power 1. 3 success and 1 failure. A coin is tossed 3 times. Come in, Bernoulli. What's the probability of exactly 2 head? 2 out of 3. The success of getting a head 1 over 2. This is the failure power 1. A basket contains 10 apples, of which 5 are rotten. What the probability that a person who buys 4 apples will get no rotten one? So here, I'm not going to buy the apple, I return it back, then I will pick another one. No, it's either arrangement or combination. Because order not important, it's combination. What do I need? I need to buy 4 apples. I don't want any rotten one. I have 10 apples. I have 5 rotten. So not rotten, 5. So 4 out of 5 over 4 out of 10. What the probability of picking a heart followed by a spade from a deck of 52 cards? So this is what arrangement order is important. So I want a spade, 1 out of 13, 1 out of 13 over 2 out of 52. Suppose it was with replacement. We do it P of the first times. We do P of spade, P of heart, then P of spade, because followed, order important. How many heart you have? 1 out of 13 over 1 out of 52, it will be 13 over 52 times 13 over 52. But this is not the case here. Why? Because without replacement, we do it either arrangement over total arrangement or combination over total combination. 2 cards are drawn from a deck of 52 cards. What the probability that the 2 cards are an ace and a 10? Order not important. An ace is 1 out of 4, a 10 1 out of 4 over, I want to pick 2 cards out of 52. The last 2 problems, a committee of 5 people is to be elected from 6 men and 9 women. I didn't say that the first one must be president, so it's whatever. If the selection is made randomly, what the probability that this committee consists of 3 men and 2 women? 3 men, so 3 out of 6, 2 women, 2 out of 9 over total 5 out of 15. Using an ordinary deck of 52 cards, what is the probability of drawing 3 black cards in a row if each drawn card is not returned to the deck? So I don't do it as Bernoulli. I want 3 black. So how many black cards I have? 3 out of 26, 3 out of 52, because I want to draw it in a row. Row order is important in a row because I want the first, then the second, then the third. So I do it arrangement. I hope that you got this probability. I'm done with the probability and counting. I hope that everything was easy. I want you to repeat this video more than 1 time. I know that it took us 48 minutes, but don't forget, you have the explanation, you have the examples, then you have 29 problems in addition to 15 problems. So here we solved more than 45, up to between 45 and 50 problems. So it will take 50 minutes in this video. So thank you for listening.